This National Instruments demonstration represents a hardware-in-the-loop test system. What we have here is we've got an actual Automotive ECU from MotoTron, and we're communicating to an hardware-in-the-loop test system, which is an NI PXI real-time controller with a series of I/O modules that are designed to communicate with the ECU. So what the hardware-in-the-loop test system does is it simulates the world around the ECU, so it simulates the engine and the actual automobile to make the ECU think that it's in an actual engine. And what we're using to simulate the engine and the automobile is an NI PXI real-time controller with an analog output module, an NI FPGA FPGA board, a CAN board, and then we also add fault insertion. So the NI FPGA board provides us with high-speed PWM signals, and the analog output module provides us with some of the traditional analog signals, and we send CAN messages to the ECU to control things like the gas and the brake. What we have down here is we've got a series of indicators representing spark plug timing and fuel injector position. And if we move up here, we've got an actual throttle body that changes as we change the values of the gas and the brake. And we've got an instrument cluster to represent speed and RPM load. So this is the hardware setup of our hardware-in-the-loop test system. We're using NI VeriStand as our user interface for the test. And as you can see here, if I change the gas and the brake, the actual speed of the automobile changes. So we're sending signals to the ECU. We're sending signals to the ECU to control the engine and the car, and as we do that, the actual closed-loop control system changes values. So we can run this test system to change the value of the car to see how the car would actually respond in real life. And we're also monitoring. If we look at another screen here, we're also monitoring fuel injector values and spark plug angle values. And we can use our NI fault insertion unit to inject faults into the system to see how the ECU would respond in the condition of a real-world fault. So all of this is great, and it allows us to manually change values in our hardware-in-the-loop test system. However, NI VeriStand adds the additional feature of being able to automate our real-time tests. So we'll bring this back so we can look at things. What I have here is the NI VeriStand stimulus profile editor, and what we can do with this is we can script our real-time tests or our real-time sequences to put the ECU in a variety of different conditions and to test a lot of corner cases. We can also use the stimulus profile editor to recreate tests that we've already run. So once we run one test, if we make a change to our software, we can perform the exact same series of tests for regression testing. So let's go ahead and run our stimulus profile. So now we're deploying the stimulus profile to the real-time engine running on the NI PXI controller, and it's taking our ECU, our whole system, through a series of tests to verify its operation. And we're also able to perform data logging simultaneously while running this real-time test. As you can see, our instrument cluster is changing values. We're moving up in speed, and our engine is moving up in RPMs, and we're also shifting on the fly. So all of this is ingrained inside of the simulation model running on the NI PXI real-time controller. And once we're done, we'll be able to analyze this data inside of our TDMS file, which logs the channels that we're interested in and allows us to graph the output of the test. So the test will be done here in just a second, and after it's done, we'll be able to look at some data. So again, we were able to take this real-time sequence and export it and use it again and again for a variety of tests. So we can run these tests on the same ECU over and over, or we could take this profile and run it on a different ECU in a different test. Should be done here in just a second, and then we'll be able to look at the data log file that we've generated. All right, so our test is done. Now, NI VeriStand has a built-in data log viewer called the TDMS file viewer. So we can go down here, open up the TDMS file viewer. We'll open up our data log. Here's the log file we just generated. And see the individual channels that we were logging, and we can also see all of the channels together. So these are the three values: the gas and the brake and the speed of the automobile. And we can zoom in and we can look at specific data points that are of interest to us. So we can log in and we can look at the individual data points to get a good view of how our test turned out. If there's a certain anomaly, we can view those individual data points to make sure that everything works the way we expect it to work. So this is just a quick demo of our NI HIL test platform, running an actual hardware in the loop validation test here at the Automotive Testing Expo.